Alright, you guys were given this worksheet today in class. If for some reason you weren't in class, it should be an attachment. Or if you lost yours, it should be an attachment. We're talking about nth roots and rational exponents. So we got to think about parts of a radical. So there you have a root that sits outside. So that little number that sits outside is the root. And then on the inside is the radicand. So that number that sits inside is what we call a radicand. If there's no number at the root spot, then it's an automatically understood 2. So if there's no number sitting right there, it's an understood 2. So to simplify a radical, okay, we've got to do some prime factorization, which means you break down that radicand into the smallest possible factors. So for the number 8, it breaks down into 4 times 2, but then the 4 breaks down into 2 times 2. So it ends up being 2 times 2 times 2. All right? Then you need to circle the groups of the root and bring them out. So what that means is if your root was 3, all right, you circle groups of 3 of the same number or variable. Okay, so if your root was 3, you circle groups of 3 for the same number or variable. And last but not least, if you bring out more than 1, okay, so once you circle it, you bring it out and set it outside. If you bring out more than 1, then you have to multiply those numbers together. So if you bring out 2 5s, for example, then you multiply those 2 5s together. So let's look at some examples. So this one's asking for the cube root of 128. So if I take a look at this problem here, I'm going to break down 128 into 2 times 2 times 2 times 2 times 2 times 2 times 2. Okay, I happen to know that it works out to be 2 to the 7th power. If you don't know this, it's an even number, you start by dividing it by 2. If you have 2 times an even number, you break it down again. And then you break it down again until you get all of your 2's. You may end up with just 2's and 3's, or 2 3's and 5's, 2 3 5's and 7's, but they're all going to be prime numbers. Alright, so I take my 7 2's, and I look here and I see that it's a 3. So I'm going to take my groups of 3. Okay, so I'm going to circle these 3 2's, I'm going to circle those 3 2's, and that's not a group of 3, so he's just left there. So for each group that I've circled, I'm going to pull out one of those things circled. So for the group of 2's, this group of 2's, I'm going to pull out a 2. For this group of 2's, I pull out the other 2. I leave this guy underneath, so it's still the third root, or the cube root of 2. And now you got to multiply those 2 together, so it's 4 cube root 2. All right, let's take a look at the next one. It's cube root of 27x cubed. So I'm going to write 27 as 3 times 3 times 3. And I'm going to write x cubed as x times x times x. So I'm going to circle groups of 3 of the same thing. So there's a group of 3 and there's a group of 3. I pull out one of this group, which is just 3. I pull out one of this group, which is just an x. There's no need to write an radical again because there's nothing left over inside. All right, if we take a look at this one, let's take a look at 32. It could be broken down into 2 times 2 times 2 times 2 times 2, which is 5 2's. And then I need to write 7 x's. X, 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 x. So now I've written them all out there, and it wants the 4th root. So for every group of 4 of the same thing, I'm going to circle it. So I've got one group of 4 2's and one group of 4 x's. So I bring out a 2, and I bring out an x. What's left under here is a 2 and 3 x's, so I multiply those back together. For these, I can separate them. So on the top, I can actually separate that into cube root of cube root of x to the 9th and cube root of 27 as 2 separate things. So then I write out my groups. So I write 9 x's and circle groups of 3 because it's a cube root. I write 27 as 3 times 3 times 3 and circle the 3 3's because it's cube root. And I end up with 1, 2, 3 sets of x's out. So it's x cubed when I multiply them back together. And then 1 3 at the bottom. Alright, so you can rewrite radicals to have rational exponents. If you'll remember, the word rational means fractional, so exponents don't always have to be whole numbers. If you have a power that's outside the parentheses, then you will take that power and put it over the root and make a fraction. So you take that number, put the power on top and root on bottom. Alright, when nothing's written there, it's an understood 1. When nothing's written here, it's an understood 2. So if we take a look at this guy, there was nothing written here or here, so I filled in my 2 and my 1. So 10w is what's underneath. I'm going to put the 1 over 2 to the 1/2 power. Right? There was nothing out here, so I put the understood 1. So 1 over 3, so I just take what's inside of here and put it to the 1 over 3 power. Now make sure that when you're writing these that it's clear that this is an exponent and it is not a fraction that's being multiplied times your radicand. Alright, there was nothing written here, so I wrote in the 2 so that I would know. So that I take what's underneath, which is the 17, and I make it 5/2. Alright, so if I take a look at this one, let me zoom back in so you can see. Alright, so the power can be underneath the radical instead of outside the parentheses as well. So when it's set up like this, then I have 2/8. So the 2 goes out over the 8, which simplifies down to 1/4. For this one, I'm going to pull the 6 out and put it over the 3. 6/3 simplifies to z squared. Other way. Alright, so you can also go backwards. So you just undo what you had done just a second ago. So you've got the power over the root, you split it up. So I've got 3 goes on the outside or on the inside of the radical, and the 5 goes out front. So you could write it either like this with a 3 inside with your radicand or outside the whole thing. Either way is totally fine. So this one can be written as cube root of 13 squared or the square of the cube root of 13. This one is got an understood 2 here and a 3 right there. Or it can be written as the square root of x cubed. Either way. I'm going to zoom in on the next one because we want to rewrite these as well. Alright, there's a lot of stuff happening there. But it says rewrite and then evaluate. Okay, so if you look, there's evaluate. So what it's expecting you to do is to say it wants the 5th root of 32 cubed. So I'm going to take 32 and write out all those negatives. -2, -2, -2, -2, -2. So the 5th root of that is just -2. And then I want to make that cubed with the 2 instead of the 3. This is supposed to be a 3. So -2 cubed is just -8. You don't have to worry about i's when these are odd numbers. When they're odd, the negative under there is just fine because the 5th root of that is -2. When I've got 64 to the 2/3 power, I'm going to take the cube root of 64 and then square that number. Okay, so when I take the cube root of 64, I'm going to rewrite it as 2 times 2 times 2 times 2 times 2 times 2. I'm going to circle my groups of 3. So what's going to come out is 2 squared, which is just 4. And then I want to square that number. So my answer is just 16. Okay, the next one, it just wants the cube root of 125, which is just 5. Alright, the negative sign just means to put your answer under the number 1. So I'm going to treat it as though it were totally positive and I get 3 cubed. And then I'm going to make that a negative. So it's just 1/27 because 3 cubed is 27. Then for this one, I'm just going to take the 4th root of 16, and then I'm going to make that negative. So the 4th root of 16 is just 2. Now I'm going to raise that to the -1 power, and that's just 1/2. Sorry. Let's zoom back out. Always got the wrong way. Alright, so the next one is a cube has a volume of 343 inches cubed, cubic inches. Find the length of the edge of the cube. Well, the sides are all the same, so it's just x times x times x. So it just wants the cube root of 343. Your calculator will do that for you if you can't recognize that as 7 cubed. And last but not least, the volume of a basketball is approximately 448.9 inches cubed. You have done this before. We divide by 4/3, we divide by pi, then we take the cube root. 4.75 meters is approximately your radius.